Hey there! In this video, I'll share with you an effective method to use titration to calculate the molar concentration of a solution. I'm Orlando Broomfield from Chemistry Core. Let's solve this chemistry exam style question together. Let's use 4 steps to set out the calculations to solve our acid-base titration question. The first step involves writing a balanced chemical equation. The balanced chemical equation for the neutralization reaction occurring has already been written. Watch this video for a demonstration on how to write a balanced chemical equation from a word equation. Ultimately, our goal is to relate the mole ratio given in the balanced chemical equation to the number of moles in the volume of each solution that is reacting. We can determine the number of moles in the sulfuric acid because it is our standard solution. A standard solution is a solution in which the concentration is known exactly. Here we are given the concentration in the question, 0.2 moles per liter, or if you prefer from your region, 0.2 moles per dm cube. And this tells us that there are 0.2 moles of sulfuric acid in 1 liter or 1 dm cube of solution. And we are also told that 14 milliliters of this solution was used in the reaction, or 14 cubic centimeters. We are unable to determine the amount of moles of sodium hydroxide present in the 21 milliliters or centimeters cube of sodium hydroxide solution used, and that is what we are asked to find out. So, in the balanced chemical equation, we are given the mole ratio, but here in our second step, we will determine the number of moles in the standard solution. Determining the number of moles in the standard solution used. So we'll use a very simple approach. If 0.2 moles of sulfuric acid are present in 1 liter, which is 1,000 milliliters, then an unknown amount, which we'll call X, of sulfuric acid is present in the amount used in the neutralization reaction, which is 14 milliliters. Using a simple method of cross multiplication, we have 0.2 times 14 is equivalent to X times 1,000. Making X the subject of the formula, we have X is equivalent to 0.2 times 14 divided by 1,000, which is equivalent to 0.0028 moles of sulfuric acid in 14 milliliters. In our third step, we will use the mole ratio given in the balanced chemical equation to determine the number of moles of sodium hydroxide in the 21 milliliters that were used. So if mole ratio of sodium hydroxide to sulfuric acid, and we'll get that from the coefficients of the reactants in the balanced chemical equation, is 2 to 1, then number of moles of sodium hydroxide is equivalent to 2 times the number of moles of sulfuric acid, which turns out to be 2 times 0.0028, which is 0.0056 moles of sodium hydroxide. And our final step will be to calculate the molarity, the molar concentration of sodium hydroxide. Now, molar concentration is the amount of moles of the solute dissolved in 1 liter or 1 dm cube or 1000 milliliters or 1000 cubic centimeters of solution. So we know how much we have in 21 milliliters, so how much will we have in 1000? So again, our simple if and then statements. If 21 milliliters of sodium hydroxide has 0.0056 moles, then 1000 ml will have an unknown number of moles of sodium hydroxide, making X the subject of the formula, will give us 1000 times 0.0056 divided by 21, which is equivalent to 0.27 moles per liter, or if you prefer, moles per dm cube of sodium hydroxide. Thank you for watching another video on solving problems in chemistry with Chemistry Core. If you were tuned in, you are now able to calculate the molar concentration of a solution of unknown concentration used in an acid-base titration by first writing the balanced chemical equation for the neutralization reaction occurring, then calculating the number of moles in the standard solution used, and finally use the mole ratio of the acid to alkali to determine the number of moles in the volume of the solution of unknown concentration used during the titration. Good luck on your exams, and I'll see you next time.